Okay, domain. Excuse me. Well, the domain, that's pretty clear. X can be anything except for 1. Okay, now let's figure out what the range is by solving this. So that would be yx minus y equals x plus 1. Now, that would be y uh, minus 1 x uh, minus y minus 1 equals 0. So basically, the way I like to find the range is I rewrite this as an equation, pretending that y is constant. And I ask, when is this solvable? And it's solvable as long as y is not 1. So that means the range is all real numbers except for 1. We can never get 1 here, which kind of makes sense because the get 1 would mean the top equals the bottom, and that can't happen. So that's the domain and the range. What is the inverse? Oh, I can get the inverse by making x the subject here. So if I solve this, I get x equals y plus 1 over y minus 1. So this is a classic example of a function that is its own inverse. And we can verify that by calculating f inverse. So f inverse x, for example, that would be f of f inverse x. Or do you know what? Actually, just to be clear, because f inverse equals f, then calculating f composed f inverse is the same as calculating f inverse composed with f, which is the same as calculating f composed with f, or f inverse composed with f inverse. It's all the same. So I'll just calculate this one and should get the identity function. So f x, that will be x plus 1 over x minus 1 plus 1 over x plus 1 over x minus 1 minus 1. That would be x plus 1 plus x minus 1 over x minus 1 over x minus 1, x plus 1 minus x plus 1. Do I have that right now? Well, they cancel. So on the top, you get 2x, and then on the bottom you get 2, which equals x, and so f inverse is equal to f inverse f, which is equal to the identity function. Yeah, so that all checks out just fine to me.